Understanding occupant comfort when designing sustainable facades in education. Welcome to Building Knowledge 101. In this video, we explore the importance of occupant comfort when designing sustainable facades in the education sector, and how replacing non-thermal components with thermally efficient frames, glass, and windows helps eliminate cold space around the exterior walls to generate greater usable interior space. Another very critical component of sustainability is interior occupant comfort. The interior conditions change project by project across the country, impacting how we approach interior occupant comfort. But the goal is always to create a comfortable, productive interior. Start by thinking of all the barriers to interior occupant comfort and what strategy you need to overcome them. Here are some common barriers to interior occupant comfort. And we can eliminate these through a good strategy of expanded glass and glazing in educational facilities. So let's take a look at each of them. Here are newer thermally efficient frames, glass and windows and doors that replace older non-thermal wood components. This eliminated the cold space around the exterior walls, gaining additional usable space on the interior. Some framing systems, such as this curtain wall, provide tie-ins for adjacent air barriers to make a consistent, complete critical barrier all the way through the building envelope. This eliminates spaces where you can have drafts or holes or gaps where air could blow through an exterior wall. Shading strategies will eliminate interior glare from direct sunlight. Here you can see a large glazed curtain wall elevation with projecting sunshades on the exterior. Here's the same elevation from the interior. The combination of the exterior shades and an interior diffusion curtain prevents glare from direct sunlight. So the curtain can be spread across the elevation at the peak of sunlight entering the building to cut down on direct sunlight, and then open back up as the sun passes over to allow more indirect light coming through. Utilization of glass for interior walls and other obstructions expands views to the exterior from a greater number of interior locations. If you look at this room here, notice there are no exterior views. So sitting in this room, you have no idea what's going on in the exterior. You don't know if it's rainy, if it's hot, if it's cold. You lack that connection to the exterior. Studies have shown how important giving people that connection from the interior to the exterior is. This is why we see many examples where interior elevations, instead of being solid surfaces, are being built with glass to allow people, regardless of where they are to the interior, to have unrestricted views on through interior walls out to the exterior. Urban environments can have large amounts of noise generated from the exterior. ASTM E90 assigns a numerical value to indicate the ability to block interior sound transmission from one room to the next. ASTM E1425 does the same, but evaluates exterior wall traveling inward. AMA 1801 combines both these standards plus an air leak test, as sound will move through air gaps in a wall. So this one combines both tests plus an air test for optimal standards of testing for ASTC and OITC performance. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.